Hey guys, we're going to look at this investigating monomials. We're going to be talking about exponents when we do this. On this first part here it says monomial. What is a monomial? The following, all of these right here, are monomials. So if we kind of look at all of them, just all the different ones that are possible, these are the things that they have in common. Notice there are all kinds of things here. We've got variables, we've got exponents, we've got a square root even down here. So there's lots of things that a monomial can be. And these are just some general, this is just a general description of what they can be. They can be numbers. Notice you got 2, 0, 5/3, square root of 5. So any kind of number is good. They can be variables. You got ABCs and Y's, Y squareds, all that's good to go. And you can have products of numbers and variables. So 2 times x is good. That's a monomial. This down here is also monomial. All you have is just products. Everything's multiplied. So those are 3 main rules of a monomial. All right, down here are things that are not monomials. Meaning that monomial means 1. So it means up here, these are all just one term. Down here, you're going to have more than one term. We have more than one term here. Because you got this plus sign in the center. Here we have more than one term. You have a minus sign. Square root of a variable can't happen. Division by x cannot happen. Those are not monomials. So there's your general descriptions of a that cannot be monomial. Variables can't be under a radical. Radical is a square root. We'll learn more radicals besides square roots. We'll do cube roots, fourth roots, different things as the semester goes on. Can't have a denominator, variable and denominator, and you can't have addition or subtraction separating numbers. Okay? Multiplication is okay, but not addition or subtraction. Okay, some vocabulary we need to know. A constant is a monomial with no variables. 5, -7, 24. These are all constants. There's no variable in there. Even square root of 5 is a constant, okay? It's always going to be that decimal number you get. In the monomial, the coefficient, we've used both these words a lot during the semester. You need to make sure you know what they are, though. The coefficient is the number of the factor before the variable. So, if these are samples, 2 and the 2x, -8.5 and -8.5 xy squared. 5/3 here, the 9 here. It's just the number in front of the variables. Okay? If you need to pause that to write those examples down, you can. The next thing we need to know about is that the degree of a monomial is the sum of the exponents on the variables. Only the variables. So, if we're looking at degree, these are all monomials. So on this one would have, this would be the same thing as x to the 1. Okay? Let me write that in so you know what I'm talking about. If it's not there, remember to be a 1. Whoa, that's not good. Let's go back. One more time. And again. Okay. Here, the exponent is 2. So that'd give you a 2. Here, we have 2 variables in the same monomial. The x would have a 1 that goes with it. So if that's the case, you're going to add those together, and you get 3. Sorry, my pen is not cooperating. Okay. Over here, again, the degree that we're going to look for is we just look at the exponents. Here, we have lots of exponents, 2, 3, 7. So again, you're going to add those up. So when you add all those up, your degree would be 12. Now here we don't have any variables. So it's kind of like if you had an x to the 0, okay? Remember that we talked about before that anything to the 0 power is 1. So it's kind of like you don't have a variable there. So the degree is 0 because there's no variable. Here the degree would be 0 because there's no variable, okay? All right. Here, these are some examples when you multiply a monomial. If you take this 5x squared y cubed and you expand it, it would look like this. X squared, so it'd be 2x's, y cubed, so it'd be 3y's, 4x, and then y to the 4th would be 4y's. So this is the same thing as this, okay? Now, when you expand it, if you reorder it and you put all your x's together and all your y's together, you get this. So this x come over here, so now we have 3 x's. These y's will come over here with these y's, so now all together we have 7 y's. So now your numbers you multiply as usual. 5 times 4, of course, would be 20. But how many x's do we have now? We have 2 here and 1 here. So altogether we have 3 x's. Here we have 3 y's and 4 y's. So altogether we'd have 7 y's. So the shortcut would be when you're multiplying when you multiply coefficients, which is what we just did. What are you going to do with the exponents? What did we do? We added them, because remember that's like a 1 being there, so we did 2 plus 1 to get that 3. So you're going to add the exponents, okay? Dividing, very similar. If you were to expand it out, now you're not actually going to do this because we may have big numbers later on. We have x to the 27th and all kinds of crazy things. But this one they went ahead and expanded. Well, x to the 4th, that's 4x's, y cubed, that's 3y's multiplied, okay? Now the division you're going to do just like you normally would. You forget that the exponents are even there, or that the variables are even there. 18 divided by 6 is 3. So your answer would be 3. Now, see how they've looped these? That means that those are in common. We have 1x down here, but 4 up here. Well, they have 1 in common, so the one of them will cancel out. Up here we have 3 y's. And down below we have 2 y's in the denominator, so 2 of the y's will cancel out. So what we're left with is, there's an x, there's 2 more x's. So altogether we have x cubed in the numerator. In the denominator we have nothing left, right? Everything canceled out, but we do have another y over here. So our final answer would be that, okay? So when you divide coefficients, the shortcut is to subtract the exponents. Okay? So, here we're doing variables multiplied by the same variable with different exponents. Bases must be the same. Well, what do they mean by base? Base is the big number. So if I have a to the m, a is the base. Okay? Of course, m is the exponent. So the big number is the base. And it doesn't matter what's variable or numbers. If you add 2 cubed, 2 is the base. Okay? Now, when you do multiplication of variables, you are going to add the exponents. So this is actually a to the m plus n. Okay? When you divide, you're actually going to subtract. So this would look like this, a to the m minus n. Okay? That's what we talked about above. All right. All right. Down here on these samples, there were some issues with the signage and everything. Make sure that on this right here, this should be a to the negative nth. I think it was missing on the worksheet. And so a to the negative nth, remember we talked about any time you have a negative exponent, that's going to cause you to reciprocate whatever you have. So if we do a sample on that, 5 to the negative 2, all that means is that I'm going to reciprocate it and put 1 over 5 squared. Okay? And then I'm going to go ahead and say what it is. 1 over 5 squared would be 1 over 25. So 1 over 25 would be your final answer on that. Okay? On here, the rule is that when you find a power of a power, you're actually going to multiply. So here I've got 5 squared 3 times. So really what that means is I have 5 squared, which is 5 times 5, but I have 3 sets of those. Well, how many 5s is that? Well, altogether that's 6 5s. That's 5 to the 6th power. Now 5 to the 6th power, remember in your calculator you can use your little exponent key, and it'll look like this in the calculator. It'll be 5 caret 6. Okay? So 5 caret 6 is going to be, oh, let me see. Hang on. All right. So 5 to the 6th power is actually 1,000, we're not small, 1,000. No, I'm sorry, 15,625. Okay? So 5 squared to the 3rd power is 15,625. But it looks like 5 to the 6th before you actually put it in the calculator. Okay? Now, on this bottom one here, this looks kind of complicated, but if it's a fraction and you're doing a power, that means you're going to do the power of the numerator. It's kind of like distributing. You're going to do the power of the numerator and power of the denominator. So 5 squared over 8, or 5 eighths squared, actually 5 squared over 8 squared, which that's easy. That's just 25 over 16. And then the last one, we're doing a power of more than one variable. Well, you're just going to distribute it to both variables. Okay, so you do a to the m and b to the m, which is what that says. Okay, so what I've got here, I know that I only have one variable, but I also have 5. So what this actually equals is 5 squared x to the 4th. Okay, because I'm doing 5 squared and then x to the 4th, we're going to do 2 times 2. So this would equal 25 x to the 4th. Are you okay with that? I hope. Okay. All right. So we'll do one more. Since this was a little bit complicated down here, let's check it. Let's do this one. Again, I'm going to distribute the 6 to both parts. So that x doesn't have an exponent, so that's like it has a 1. So that would be 1 times 6, so that would be x to the 6th. 2 times 6 is 12, so that would be 1 to the 12th. So that would be the final answer. Okay? Now, what I want you to do before you come in tomorrow, I want you to finish the rest of these samples. We'll check them when you come in, see how you did. And then on the next page, on the next page, I'd like you to go ahead and at least attempt to do 1, 2, 3, 4, getting a little tricky here, and 5. See what you can do with that. Just see what you come up with. See if you can get it right. Because if you can figure these out on your own, you'll be way better off. All right, y'all have a good evening.